Hello everyone, and welcome to our webinar on the new primary production and processing standards for horticulture. I'm Elizabeth Frankish, and here with me today is Joel Dinsdale. Most of you will know Joel, who's the Quality Assurance Coordinator for VegetablesWA. Joel has a lot of experience in advising and auditing QA systems on farms. He's also qualified to collect produce and water samples so that laboratories receive valid samples for testing. I'm a microbiologist and consult through my company Food Minds. I have experience running laboratories and testing those samples and interpreting the results. I've also spent decades working with all stages of horticulture supply chains on risk assessment and advising on the most effective food safety management practices across all food sectors. My work has also included developing food safety guidelines for a range of horticultural products. Over the last year, I've been working with VegetablesWA and Joel to deliver relevant information and guidance materials ready for the implementation of the new PPP standards. Today, we plan to provide you with information about the standards, help you identify the hazards in your operations, and talk about how to minimise risk from those hazards so that you can have more confidence in producing safe food and complying with the regulations. The webinar is divided into 3 parts as shown, and it's being recorded so that you can view the different sections at a later time and focus on the areas you need to learn more about. So in part 1, we'll give some background to the standards and briefly talk about the range of hazards in fresh produce. In part 2, we'll provide more detailed information on controlling the hazards to reduce risk and discuss the importance of produce traceability. The third part will cover how you should proceed to meet the requirements and where to find more information. Joel and I will also discuss some common questions we hear that we think need addressing. We know that foodborne illness outbreaks caused by fresh produce are increasing worldwide. And we also know that putting in place food safety controls at the start of the fresh produce supply chain is the most effective way to prevent outbreaks. So Food Standards Australia New Zealand has developed standards for the high-risk commodities, melons, leafy vegetables and berries. The main reason these 3 commodity groups are categorised as high risk is because contaminated lots of these produce items have caused foodborne illness outbreaks in Australia. From the 12th of February this year, you're legally required to comply with the standards. Depending on what you grow, you need to either register with or notify your local government of your business operations, and you may need to have a written food safety program. This means you need to have evidence that you've identified potential hazards in your operations and have implemented control measures for each of these hazards. The standards also require you to verify that the control measures are effective. In other words, have the evidence they actually work. Growing berries doesn't require a written food safety plan in the standards. However, writing a food safety plan has proven to be the most effective way for people to know what they're meant to do. Now, the new requirements may sound onerous, but mostly complying with the standards should be fairly simple because you will already have some food safety controls in place, and a lot of food safety is using common sense to prevent contamination. Also, this online webinar is just one example of a lot of information and support that's available to guide growers through the changes. When you go to the Western Australian Health Department website, there are links to the standards and other information for growers produced by Food Standards Australia New Zealand. We will take you through more detail of what you need to do before February later in the webinar. We're now going to talk about food safety hazards and how you can control them, which takes us through all the topics covered in the standards. But firstly, it's worth noting that the standards, as they're written, convey the basic expectation that growers will implement and follow good agricultural practices and good hygienic practices. Potential food safety hazards during growing, harvesting and post-harvest handling of produce include physical hazards, microbial hazards and chemical hazards, including allergens. They include hazards you will be familiar with, like pieces of wood, plastic or metal from equipment. However, physical hazards also include weed plants that could be toxic, as happened in 2022 with intoxication of nearly 200 people from thorn apple that contaminated baby spinach grown in Victoria. Other weed plants may cause allergic reactions. You will also be aware of possible chemical hazards. Chemicals such as pesticides and herbicides can become a food safety hazard if they're applied at levels above the permitted maximum residue limit, or if they're applied to a crop for which there's no permit. So it is expected that you have controls in place to prevent those types of incidents. Microbial hazards like E. coli, Listeria monocytogenes and Salmonella are usually more complex to manage because we need to consider not only the potential for them to contaminate the crop, but also their ability to survive and grow on the crop, from the field through to post-harvest activities and along the supply chain to the consumer. Also, they can contaminate produce both directly and indirectly, which we'll explore further in the next part of the webinar. Like microbial hazards, allergens can contaminate crops via some of the inputs to crop production. It's important to know, for example, if soil additives and mulches used could contain products or waste products of nuts, fish, crustaceans or eggs, or any of the other allergens listed in the Food Standards Code. If so, you will need to have an allergen management plan in place. All of the inputs listed on this slide are a potential source of microbial hazards like E. coli, Listeria monocytogenes and Salmonella. But some might also have allergens, as already mentioned, and chemical hazards. These hazard sources include all the common farm inputs like irrigation water, soil amendments, equipment and people. The circumstances that cause these inputs to contain harmful agents vary, and the level of risk from the hazards will change over time. Also, the likelihood of some microbial hazards being present in dangerous numbers is influenced by environmental factors such as temperature and adverse weather events. The presence of chemicals will also be influenced by environmental factors and activities on neighbouring properties. The seeds and seedlings of leafy vegetables, in particular lettuces and sprouts, are known to potentially harbour foodborne pathogens, which is why they're specified for control in the leafy vegetable standards. And of course, sprouts have their own standards already. So it's no coincidence that the new standards require you to have controls in place to manage these inputs and the environment where produce is grown, processed and stored. It's expected that you will control and manage irrigation water and post-harvest water where used to prevent and/or reduce contamination. Buildings and equipment must be hygienically managed to prevent contamination, and temperature control of harvested produce needs to be considered. Importantly, the standards require that everyone who works with fresh produce not only follows good hygiene practices, but also has the appropriate knowledge and skills for the work they perform. Traceability of produce batches is an additional requirement that we will spend more time on in part 2 of this webinar. The sources of hazards and other factors often interact, and it's this interaction which often causes a potential hazard to become a risk to consumer health and makes compliance with regulations more challenging. For example, applying the correct level of a pesticide depends on the equipment used to be properly calibrated, and it also depends on the person responsible being appropriately trained. having the right skills for the job. It also relies on the supplier of the product to have formulated the chemical correctly, so that when you prepare it according to the label instructions, you can have confidence you're applying the correct amount. Another example is where heavy rain and hail can damage crops, causing bruising and wounds in the produce. If the soil they're growing in carries a pathogen such as salmonella, it can be splashed onto the plants during the storm, and the damaged areas then provide moisture and nutrients for the salmonella to survive and grow. Other management factors like temperature control of harvested produce and any washing and sanitising of the produce subsequently might then determine the level of risk to the consumer. So you can see why good food safety management requires having multiple controls in place, being aware of events and activities that might affect risk, and being prepared to take action when it's needed. So this ends part 1 of our introduction to the regulations and food safety hazards. So far, we've reviewed the types of food safety hazards and how they can contaminate crops through inputs to growing and other farm activities. We will now turn to the practicalities of how the hazards can be controlled and some of the challenges in managing food safety. At the end of this session, we'll give you some guidance on how to meet the traceability requirements of the new standards. Physical hazards are a constant threat in farm operations, but there are some simple measures you can take to reduce the likelihood of harm. Reconciling equipment every day or shift prevents whole items or pieces from damaged equipment finding their way into bins or bags of produce. Having in place a preventive maintenance program for equipment not only prevents loose and damaged items like bolts and pieces of hard plastic entering the crop, either pre or post-harvest, but also minimises costly downtime of machinery and vehicles. Clothing and protective clothing worn in the field or in packhouses shouldn't have frayed edges, and fasteners such as buttons should be securely in place. Clean clothing helps prevent cross-contamination of microorganisms to produce, and this is particularly important where gloves are used, which applies to both disposable and reusable gloves. Colour coding is a simple but effective way to help workers notice when a foreign body accidentally enters produce bins. But training your people to be observant throughout growing, harvesting and post-harvest activities is critical in preventing physical hazards. The many types of chemical hazards means multiple controls are needed, but common to all is the need to have current knowledge of the regulations and label requirements. Having good relationships with reputable chemical suppliers is the foundation for control of chemical hazards, but ultimately you are responsible for the correct use of agricultural chemicals. In addition to agricultural chemicals, fresh produce must meet standards for heavy metal contamination. These hazards can be controlled by appropriate soil and water management and choices of lower risk crops when known. If increasing soil organic matter is needed to help mitigate heavy metal uptake by crops, then you will also need to make sure that composts and manures used don't contain heavy metals or in fact harmful microorganisms. Compliance with best practice storage of chemicals manages your personal safety and food safety, and you need to consider the location of where activities involving chemicals are carried out to prevent contaminating water sources. These actions will ensure you prevent inadvertent entry of chemicals into product. Detergents and sanitisers used to clean equipment should be food grade to prevent any residues contaminating the produce. We use food-grade detergents and sanitisers because they can be effectively rinsed off surfaces. Otherwise, these products can cause illness. Knowing the history of your farm can determine the likely presence of environmental pollutants and drawing a site map of your operations showing neighbouring land use, which is a requirement of the standards, will alert you to potential contamination from runoff. We'll now turn our attention to the microbial pathogens. These three bacteria, Salmonella, Listeria monocytogenes, and the pathogenic E. coli, which in fact includes many different E. coli, are not the only microbial hazards, also known as foodborne pathogens, but are currently the main pathogens of concern in Australia. There are many reasons why we have outbreaks caused by these pathogens in fresh produce. However, the main reasons we know so far are that these bacteria can survive well in the common production inputs, and they also survive on dust that's blown onto crops. Depending on environmental conditions, such as temperature, solar radiation, and moisture, they can survive in soil and water for weeks to months. They're regarded as environmental opportunists because they are attracted to plant nutrients and use those nutrients to grow on the plant. They can then survive for long periods, and the same is true for survival on equipment surfaces that aren't adequately cleaned and sanitised. Although foodborne pathogens generally prefer moist conditions, they can also tolerate dry conditions, and over time they can become resistant to disinfectants and sanitisers. As you will know, farm and packhouse equipment is difficult to clean and sanitise, so visual inspection for cleanliness is important. However, absence of obvious dirt doesn't guarantee an absence of pathogens because they're much smaller than the dirt particles and might be attached in crevices and cracks. Likewise, plant surfaces provide niches for pathogens where they are protected from the action of sanitisers. The rough surfaces of rock melons, leafy vegetables and berries have many areas where microbes can persist, attach and grow. There are also areas like stem scars where microorganisms can infiltrate and survive in the flesh. This can occur either during growing or post-harvest washing. This slide shows an approximate relative size of an E. coli cell to a plant stomata. So you can see how easily microorganisms fit into the pores on plant surfaces and give some indication as to why sanitisers can't remove them all. If your operation includes post-harvest washing, be aware that this activity only reduces microbial numbers a small amount. And while that's better than nothing, it's just one control measure that needs to be used alongside many other controls. The value of post-harvest washing is dependent on using clean water at the right pH with the correct sanitizer dosage and an effective contact time. These are factors that need to be determined for each operation, and more detail on water sanitisation can be found in the Guidelines for Fresh Produce Food Safety and the Melon Food Safety Best Practice Guide, so please have a look at those. We will now focus on the key areas for control. For each of these areas, VegetablesWA has produced a risk assessment checklist that will help you write a food safety management statement. The purpose of the checklist is to guide you in identifying what needs to be done to comply with the standards and help you assess if your current controls are sufficient. The checklists will be made available on the WA Health Department website, shown here, and VegetablesWA will also make them available, so please contact VegetablesWA through their website. This slide shows the list of checklists that has been prepared, and you will use these to conduct your risk assessments in each critical area of operations. They cover each key item listed in the standards. And each checklist references other checklists that are relevant to the topic, so you can gain a more holistic view of controls needed. Personal hygiene requirements are common to all food production. And the most important message here is that washing hands for 20 seconds with soap and water, followed by thorough drying, is the best way to remove contamination. Then a hand sanitizer can be used. Effective hand washing prevents contamination from people, the pathogens being transferred to other surfaces. And checklist 13 covers people, health and hygiene. A separate checklist 14 covers people, skills and knowledge. Checklist 8 assesses risk relating to equipment hygiene. Assessing bins and harvesting equipment before harvest begins is important to prevent use of damaged and cracked items that can be a source of microbial contaminants. Clear separation of clean and dirty equipment and stacking clean bins to prevent contamination before use helps people follow good hygiene rules. Having good organisation in the areas designated for cleaning and sanitising equipment, like crates and knives, is essential to help people follow correct procedures and prevent cross-contamination to produce and other clean items. Effective cleaning involves scrubbing equipment with clean brushes to remove dirt, washing with a detergent, then rinsing under running water, followed by immersion in a sanitizer solution. It's a good idea to have these written instructions or a cleaning poster at the cleaning station as a reminder of the correct procedures. If you have more complex equipment, such as harvested or packing lines, be aware that there are many places where microorganisms can attach and survive for long periods. For example, rollers, brushes, underneath conveyor belts and equipment joints and welds are hotspots for pathogen survival. Thorough cleaning and sanitising is essential, and dismantling this type of equipment on a regular basis is needed for effective cleaning. This helps prevent Listeria survival and its transfer to produce. Checklist 8 also covers hygiene control in your farm buildings. Pest control in and around sheds should be in place and regularly monitored, and you should record the results of the checks conducted and any actions you take as a result of those checks. If harvested produce isn't covered during transport to the shed or while in the shed, it may be susceptible to contamination from dust, birds or insects, so you'll need to consider how you control this risk. Additional controls to prevent contamination include good drainage to prevent water pooling in and around the shed and regular removal of waste and rubbish from the shed. Failure to properly control each of these issues will allow the spread of pathogens to produce. How you store harvested and packed produce affects the likelihood of post-harvest contamination. Routine use of pallets to keep boxes and crates off the floor and away from walls prevents water getting into produce and discourages insects. If you have cold rooms, it's important also to keep crates and boxes away from the drip line of condensers. We have been involved with contamination of fruit with Listeria monocytogenes from a condenser unit, and when that happens, there's a risk of having to conduct a food recall, not to mention the expense of all the extra testing that needs to be conducted. Controls for both irrigation water and post-harvest water when used are required in the new standards. Checklists 4 and 5 respectively guide you through assessing risk from water. The standards expect you to be aware of any potential sources of contamination in irrigation water. Irrigation water can become contaminated directly and indirectly from many sources, including wildlife, domestic animals, and runoff. The checklist walks you through the main factors to consider, but it's critical that you stay alert to any changes, events, or activities that might cause unusual levels of contamination and increase risk to crops. In such cases, which might result in high levels of E. coli, for example, Australian industry guidelines instruct the use of a 48-hour time period between irrigation and harvest to allow for pathogen die-off. If you undertake a post-harvest wash step, the use of running water will be the least risky. If you dump produce into wash tubs, the water needs to be replaced regularly because as soil and debris build up, any sanitizers you add won't work effectively with this high organic load. So it's best to set up a water change schedule, preferably based on test data gathered or a consultant's advice. The water should be disposed of so that drainage doesn't cross-contaminate clean produce. Hailstorms, heavy rain and dust storms are the most likely severe weather events that can damage crops and increase risks to fresh produce safety. Wounds allow pathogens to enter the flesh of fruit and vegetables, and we know pathogens can grow in bruised areas. Also, the paddocks might flood, causing edible parts of a crop to come into direct contact with soil, increasing risk. A dust storm was a major contributing factor to the Listeria monocytogenes outbreak in New South Wales rock mountains in 2018. This outbreak highlighted the importance of continual risk assessment in operations and the need to adjust food safety controls at times of heightened risk. In Western Australia, we've experienced high numbers of wildlife gathering around surface water during bushfires. So having plans in place for monitoring and treating irrigation water at these times of higher risk and or using a longer time interval between irrigation and harvest is part of good food safety management. If an area of a crop is flooded or subjected to water pooling, the first step is to assess the cause, and then decisions can be made about further action. For example, water pooling might occur from a broken irrigation line, so the level of risk to the harvestable portion of the crop will depend on the water source. In this instance, there's likely to be less risk than if there's flooding from runoff upstream. Checklist 12 guides you through the main considerations. Now, thinking about all the hazards we've discussed, you and the people working with you are the best controls through your knowledge, your awareness, and your willingness to reduce risks. We can use the plan, do, check, act cycle with a food safety twist to comply with the new standards and continuously improve food safety. You must plan how to reduce food safety hazards in your operation because each operation is unique. Your inputs, growing techniques, and staffing all vary, so your solutions to control hazards may also vary. The whole team is needed to follow the rules and the correct procedures all the time to achieve food safety success. You need to check if the controls in place are actually working, and if there's no evidence they work, then changes should be made to get back on track. You might see, for example, an increase in customer complaints, which alerts you to a loss of control, in which case you can investigate the root cause of the problem and set about adjusting the controls or implementing new controls. Planning hazard control is the foundation of a food safety program or food safety management statement as outlined in the Health Department document you will access. Always acting in the right food safety way means you have a good food safety culture. Checks that your controls are working is the verification part of a food safety program, and acting on those controls, acting on those findings is to fix something that's out of control, and that's taking corrective action. All of this results in continuous improvement in your operations. The ability to trace your produce and the hazardous inputs used to grow it is a requirement of the standards, because this information is needed if there's a food safety incident involving the type of fruits or vegetables you grow. If your product is involved in the incident, it gives you the ability to isolate contaminated product to prevent harm or further harm to consumers. Importantly, good traceability allows the health authorities to more rapidly pinpoint where the contaminated products originated, which can help minimise damage to your business and the broader industry. Good traceability, of course, also means you have the evidence when your product is not the cause of the problem. This table shows the one back, one forward rule, which should be followed, where you keep records of harvest location and the harvesters, what batches of inputs were used to grow the crop, such as soil amendments, fertilisers and chemicals, and where the batches are sold. See checklist 9 to follow the risk assessment. Please note that for leafy vegetables, you need traceability of seeds or seedling batches because also, as discussed earlier, they can be a source of microbial contaminants like salmonella. This concludes the information on hazard control and traceability and which checklists to use for your risk assessment. We'll now outline the next steps to take and where to find further information, then move to some questions and answers. To summarise the key points so far in this webinar, growers need to implement basic food safety controls for the identified hazards to reduce risk. These controls should be centred around personal hygiene, equipment and building hygiene, water management, both pre-harvest and post-harvest, control of chemicals, risk assessment of changing environmental conditions, and traceability of finished product and major inputs. You may have seen this decision guide in a recent WA Grower magazine. In Western Australia, if you're certified to a GFSI scheme, local government will not be undertaking risk assessment or auditing on your property. However, if you're not certified to a GFSI scheme and you grow melons and or leafy vegetables, you will be audited by local government, and you will also need to complete the food safety management statement they provide, which is essentially a summary of a food safety program. That statement needs to be submitted to your local government for approval. If you grow melons or leafy vegetables, you will also need to register with your local government as a food business. Over time, environmental health officers will conduct routine risk assessment on site to check that you've been operating according to your food safety management statement. If you grow berries, you will only need to notify your local government authority of your food business. Whilst there's no requirement to complete a food safety management statement and submit to local government if you're a berry grower, and they won't be directly auditing berry operations, the berry standard does require that you have controls in place to manage hazards from inputs to produce safe food, and that you comply with traceability requirements. The Health Department website has links to the forms you need to complete and links to each of the standards. It will also give access to the checklists I've discussed, and this webinar will also be uploaded soon. Further useful information can also be found on the FSANZ website and the Fresh Produce Safety Centre website. We'll now move to some questions and answers to help guide you further in meeting your legal obligations. So when reviewing lab results for MRL testing, Joel, there were times when the residue limit was breached, but growers often would not understand why. They didn't know what might have gone wrong. And so one question I always asked was, had they complied with the withholding period? So can you explain the relationship between withholding period and the earliest harvest date?
Yeah, so if the date and time of application is, let's say, 6 a.m. on the 1st of January, and the chemical label states that the withholding period is 1 day, then the earliest harvest date would be 6 o'clock on the 2nd of January to ensure that withholding period of 24 hours has passed.
Sure. So, Joel, growers need to know what specific parameters they should validate and verify in their operations. How should growers validate spray equipment to ensure that the right amount of chemical is being applied?
Yeah, so growers need to confirm the total output of each nozzle, which equates to the total output of the entire machine. They need to make sure that each nozzle is consistent in its output. A great resource that you can use is the Department of Primary Industries and Regional Development's website, where they have resources available.
So let's talk about water next. In the guidelines for fresh produce food safety, there are limits for E. coli in both pre and post-harvest water. Given that there's a requirement to test water, Joel, if a grower has a scenario where they have multiple bores pumping into a dam, does the grower need to test each of those separate water sources going into the dam to comply?
So practically speaking, I think if we took a sample from the dam, or perhaps even closer to the output point, and the results met the guidelines, then it's probably not necessary to do any further testing. But of course, this is a bit of a case-by-case, time-by-time thing, so you should always double-check.
Yeah, that makes sense.
So Elizabeth, the standards document that you must clean and sanitise your equipment as frequently as required to maintain food safety. How does business determine the frequency of cleaning and sanitation?
Yeah, well, look, the only way to be truly confident about cleaning and sanitisation is to gather evidence through having an environmental monitoring program. And so you really do need to take microbial swabs to collect the data that can then aid decision-making about what frequency is appropriate. Just like water testing, though, you need to remember that swabbing is a snapshot in time. So, you know, variations in the program might be required from time to time, especially when troubleshooting needs to be undertaken. But certainly reviewing the trends of swab results will give growers the information they need to make objective decisions about their cleaning and sanitising. So we just wanted to cover a little bit about traceability now. Joel, is a pallet label sufficient when implementing traceability to meet the standards?
It's a bit of a tricky question, but I think given that you're never really likely to know what might happen to the pallet further down the supply chain, I think it's probably important that each and every standard keeping unit or unit of sale is labelled with the batch details to ensure that traceability is maintained. So I guess if a pallet is broken down to fulfil multiple orders, you are maintaining documented traceability. So Elizabeth, talking about EHO evidence gathering, what approach do you think the EHOs will take when conducting on-site risk assessments?
Well, there'll be some slight differences in approaches, I'm sure, but I think common to all of the EHOs will be that they'll want to see objective evidence in the business that they're meeting the standards. So growers should really take the opportunity to collaborate with the EHOs and that way determine the best pathways to maintain ongoing food safety objectives. It is important that the growers maintain good communication with the EHOs so that you can learn from each other, because the EHOs will want to learn and understand the grower's business. And the growers should take the opportunity to use the knowledge that the EHOs have accumulated to help with prioritising what direction they take in food safety control. Well, I think we've probably covered a few things there, Joel, so we might wrap up now. And I just wanted to thank everyone for watching this webinar. We hope that the information we've provided today has been useful. And please, if you want any further help, make sure you make good use of the resources that are available on the FSANZ website, the Safe Horticulture Australia document, which you will find on FSANZ's website. And also please go to the Fresh Produce Safety Centre website and download a copy of the guidelines for fresh produce food safety. And also, of course, at any time you can contact Joel here, who's always willing to provide some information and help. And that's joel.dinsdale@vegetableswa.com.au. So thanks for joining us.